There's a popular kind of toy sold along with fireworks around 4th of July in the United States that's called a sugar snake, black snake, carbon snake, or pharaoh serpent. Originally, this reaction was done with mercury 2 thiocyanate, but that's toxic and it ended up being banned in most places. However, it can still be done as a lab experiment. It is also sometimes done in chemistry labs using concentrated sulfuric acid. But neither concentrated sulfuric acid nor mercury 2 thiocyanate are very easy or safe for the average do-it-yourselfer to get their hands on. So we'll be demonstrating how to do this with a much simpler and safer way. Today's demonstration will use ordinary table sugar and baking soda. To do this, you will need a heat-proof dish, sand or litter, a fuel source like alcohol or lighter fluid, baking soda, and sugar, as well as a long lighter or long matches. So to do this, we are going to use plain white table sugar and baking soda. I have this in a ratio of 4 parts sugar to 1 part baking soda. I'm going to mix these two together. And then here in my heat-proof container, I have, this is cat litter, but you can also use sand. I just happen to not have sand. And I'm using 70% isopropyl alcohol as my fuel. You can also use lighter fluid. And the first thing that you're going to do is you're going to get your sand or litter nicely saturated there. And then you're going to make a little impression in that sand and pour in the mixture that you just did with the 4 parts sugar to 1 part baking soda. Pile. And now I am going to light it. I'm going to try to light it as close to the middle as I can, otherwise it will happen, but it will kind of be in a uneven kind of pattern when it gets going. And we will give that a few minutes and we will watch to see what happens. You can see it's starting to grow. We'll zoom in with my camera. And you can see our carbon snakes are starting to grow now. I'm not really this close to the flame, I have it zoomed in. This reaction can take a few minutes to get started and it can burn for 20 to 30 minutes, so you want to make sure that you are doing it in a place where you're not going to be leaving it unattended. I'm doing it here on the stovetop. I have some foil down. It shouldn't make really a mess because anything that comes out of the top of this cauldron here is going to be carbon ash, so it smells like marshmallows, but it's not going to be sticky or anything like that. Once it starts going, then you get to see these big columns growing. And I'll check back in on it in a few minutes. So it looks like it is all extinguished now. There's no little sparks or anything, no flames, but I'm gonna touch it with this knife rather than my hands anyway. And that's just some carbon ash there. A little bit of melted sugar down there at the bottom. The idea behind this reaction is this. When heated, sugar will decompose into elemental carbon and water. The baking soda will break down into water, carbon dioxide, and sodium carbonate which is also known as washing soda or soda ash. The black snake part that you see in this demonstration is carbon ash. It is being pushed upwards and outwards by the steam and the carbon dioxide gas that are produced by the breakdown of the sugar and the baking soda. I will use the word sugar here to refer to table sugar, but technically a sugar is a category of biomolecule called a carbohydrate. The word carbohydrate refers to carbon that has been hydrated, that is, carbon and water. The simplest type of sugar is called a monosaccharide, and this includes things like glucose, fructose, galactose, and ribose and deoxyribose, which are the sugar backbones of RNA and DNA respectively. These monosaccharides are the building blocks for more complex carbohydrates whose properties depend on the number of monosaccharides that are linked together and the way in which they are linked. The name for white sugar is sucrose. Sucrose is a disaccharide. It is made up of two monosaccharides, fructose and glucose, linked together. Instead of melting like many substances, sugar decomposes at a high temperature, around 185 degrees Celsius. So what's the difference between melting and decomposition? Melting is when a substance changes from a solid phase to a liquid phase, but is molecularly unchanged. Liquid water and solid ice are both H2O. In a decomposition reaction, the molecule actually breaks down into smaller parts and is no longer the same substance. In this case, the sugar will break down into carbon and water. If you watched my elephant toothpaste video, you're already familiar with another kind of decomposition reaction, that of hydrogen peroxide into water and oxygen. If you haven't watched that video, go ahead and take a look at that to understand decomposition. The fact that sugar breaks down into carbon and water when heated is what gives caramel its color, makes marshmallows black when you're making s'mores, and gives creme brulee that nice black crust. Another name for this specific kind of reaction that is happening here with the sugar is a dehydration reaction, because we're taking the water molecules H2O out of the sugar. This demonstration is a fun and educational alternative to traditional fireworks this 4th of July, especially if you live in an area where it is unsafe or illegal to set off traditional fireworks. But as always, use common sense about the time and place in which you are performing this demonstration.